everyone, welcome back to our YouTube channel, Becoming a ROS Developer. So today we've got Josue. We has completed the course ROS Basics with Python, and he will be giving a presentation about his project, how he managed to do it, and then we'll get into the details about the code base. So first of all, we'll see a demonstration on the real robot as always, and then we'll get into the nitty-gritties later. So I'll now hand over the platform to him and he can begin his presentation. Okay, Josue, over to you.
All right. So I'm just gonna right now. I'm just gonna move the robot to where is it?
Right, there we go.
It doesn't seem to be
Responding.
moving. Oh, there we go.
Okay.
Probably
yeah,
just
lag.
probably just latency. Yeah. Sorry about that. It's raining over here.
It's all right.
There we go. Go a bit forward. Down. Routines. Really? All right. Now we're just building the packages. Then we do source install bash. And now we're just gonna launch the code from the package. Oh my goodness. Ah, there we go. Alrighty.
All right.
And let me, oh, my goodness. There we go. Alrighty. So right now it records the first odometry, and now it's searching for the wall.
Okay.
Takes a little bit. Sometimes this happens, sometimes it gets it right away, but it's searching for the wall right now. It's found the wall.
Okay.
Now it's rotating to the right using the indice.
Okay, I see.
All right, goal accepted. All right. It's a little bit shaky, but as you can tell, it's doing its best to follow the wall and stay between 0.2 meters and 0.3 meters.
0.3, yes.
Yep. And we're just gonna avoid the corner a little bit. Yep, there we go. We go a little bit far off and then we correct itself.
Okay.
Yep. Like so. Yep. And then hopefully we should get between 5 centimeters to our origin, our starting point right here.
All right.
Come on. 0.3, 0.2, so close. 0.0. Okay, well,
all right.
we didn't get less than 5 centimeters, so it'll
it didn't
keep going
stop.
until that happens.
I see.
Yeah.
I see.
Yeah. That's sometimes it does it, sometimes it just depends.
Okay. It's all right. You can go on.
All right. All right, I will stop the robot from moving. There we go. All right. Okay. Now I'll move on to my slides that I prepared. Slideshow from the beginning. All right. So everyone, this is ROS Basics in 5 days with Python.
Yeah.
Next slide. So a little bit about me. My name is Josue Valladares Jr. I'm the second generation college student. My father was before me. He's actually Josue Senior. I'm a senior electrical engineer at the University of Houston. And some interesting facts about me is around 30 years ago, my family came from Mexico to the United States and started their own business, and it's been going pretty all right for the past 30 years. I raised chickens in my backyard. It's has its ups and downs, but they've mostly been ups right now because of the price of eggs.
All right.
And I compute to campus pretty much. Anyways, the goal of our ROS check was to locate the nearest wall by having the robot search for it, in
Mm-hmm.
which case you saw it turned, faced it, moved closer to it if it was greater than zero point 0.3 meters away, and then
Yes.
it rotated once again so that the right side of the robot and the wall were parallel to each other.
Mm-hmm.
And then we had the robot move around the arena, following the right wall
Mm-hmm.
while maintaining that set distance between 0.2 meters and zero point 0.3 meters.
Yes.
While this was happening, we had the robot, if you saw in the beginning, it started by tracking the original position with the first odom.
You're right.
And then as it was moving, it constantly kept updating, I believe, what you wanted it every second of telling us the distance from the starting point
Yes.
and the distance that it had traveled in total. And then, of course, we didn't see it happen, but had the robot been less than 5 centimeters away from the starting point,
Mm-hmm.
it would have stopped and returned the total list of points traveled.
Yes.
So, a quick overview of the robot and its differences from the simulation. The simulation, it had around 360 data points with its angular range going from 0 to 360
Mm-hmm.
degrees or 0 to 2 pi. The front of the robot was at 0, at index 0, or I guess you'd say degree 0,
Mm-hmm.
while the right side of it was about 270. I'm assuming it went 0, 90, 180, 270,
Yeah.
something like that.
Yeah.
Whereas the real robot had about 720 data points, and its angular range went from negative pi to pi, which is
Okay.
about what, negative 180 degrees to 180.
Right.
Yep. The front of the robot was at 360 data point, whereas the right side was at 180.
Okay.
Those are just some differences that I noticed.
Okay. Okay. Yeah. Very good observation there.
Now, the ROS check tells us to start with section 1, 2, and 3. I'm going to explain the code, the setup, in the way that it wanted us to in the main launch file, which was the wall finder, the
Mm-hmm.
odometry,
Mm-hmm.
and then the wall following behavior.
All right.
So right here for our wall finder service, we had to, of course, subscribe to, what was it? I'm blanking, sorry. We had to subscribe and publish two different services.
Mm-hmm.
And right here, I have the main the main code right here, which I call locate to wall. Minimum index is, how would I say, describe? It is the smallest value at that index. So while the smallest value isn't in front of the robot, which means it's not facing it directly, it'll
Mm-hmm.
keep turning left or right depending on where it's facing. And once it actually does face the wall, then it will stop and then start moving towards the wall. I put a little time.sleep right there just so we can have some time for the sensor to update.
Mm-hmm.
And then, of course, we move to the wall. If, let's say, the robot was zero point 0.4 meters away, it would move towards it until it was less than, less than 0 0.3 meters. Then it would stop and then it would begin to rotate again. So while the smallest index, which is would be facing the wall at 180,
Mm-hmm.
isn't there, it will start turning left and turning right. And once it actually is parallel, then it will stop turning.
All right.
All right. Here we have our odometry callback. Here we append right here. We get our first odometry value and we update to the current position. Now, as to calculate the original distance to the position, we just update it accordingly every second so often. And to, sorry, to find out the distance that we've traveled, we use the Euclidean distance formula in 2D, which
Mm-hmm.
is just, I believe, what the square root of the current distance minus the last distance or the first distance squared and then
Mm-hmm.
square rooted,
Mm-hmm.
kind of like a triangle.
Right. Right.
Yep. And then if you see at the bottom right here, distance to start, it would have, if it was less than 5 centimeters, like intended, it would have broken out of that and then sent the goal handle and the result to wall following.
Okay. Okay.
And then wall following right here, we have a callback to the laser, to the laser scan. Sorry. Right here, we just index the front laser to index 360 and the right laser to 180. And
Mm-hmm.
we start wall following. And wall following, what that does is when the front laser is less than 0.5 meters away, which means it's about to hit that space where there's a wall in front of it and it needs to turn left. Then we do corner avoidance, which will turn it left, which is right here. The reason that I chose a higher speed
Mm-hmm.
than recommended is I believe the professor recommended from 0 to 0.49 radians per second or meters per second.
All right. All
I
right.
chose it so that it would, I tried doing that and sometimes it would work, sometimes it would turn left, other times it would just bump into the wall. So I chose a higher value just to make sure it actually turns left.
Okay. So you wanted to make it 10 quicker than before
Then
getting hitting
yes.
into the wall. Okay. I see.
Mhm, mhm. And then sorry, then we move. If not, then we move along the wall right here.
Mm-hmm.
Now move with wall. This uses a proportional controller. I understand that it is probably better to use a while statement or while loop like in wall finder, but this is just easier and for the sake of time.
Yeah. Okay.
So what so what this does is we want to be in between zero point 0.2 and zero point 0.3 meters.
Right.
So our ideal is right in between at 0.25. So what this does is this calculates the error between the distance in self dot right laser
Mm-hmm.
minus the ideal.
Right.
And then we set the linear speed to zero point 0.1 and our angular speed, or I guess radians per second, to -7 times the error.
Right. Right.
Mhm. And then this bottom right here is just to enforce that we don't go too fast or and cause the robot to tip over.
Okay.
Yep. And then this bottom one is just to stop it completely, which
Um,
would have happened if, yep.
can you explain how you chose your the number that you used as your KP for your proportional controller?
I just sort of started like in starting from -1
Mm-hmm.
all the way to -10, and
And see.
7 just seemed like the sweet spot. Yeah.
Okay. Okay. And see how it responds.
Hmm.
Okay. All right.
Yep.
All good. All good.
And that brings us to the end of the presentation right there.
All
Let
right.
me go back to the code real quick.
All right. Very
Code edit.
very nice presentation. Thanks for integrating the code in the slides as well. Then we don't have to constantly check your code base in the actual folder. Um,
There we go. Mhm.
all right. Maybe for a couple of things we will check, but then I would like to ask you a couple of questions. So
Mhm.
you did notice that it didn't stop at the very beginning, right? Where you wanted
Yep.
it to stop, right after completing the loop.
Yeah. Yes.
And
Mhm.
I'd like you to explain to me how could you have made it better? How could you have made it stop, right?
Okay.
Within your understanding of the project, right? What could you have changed to make it stop?
To make it stop right there.
Right there,
Um,
yeah.
I would have probably tested it and seen how much it travels
Right, okay.
around the total distance traveled.
All
And
right,
then more than likely, I would have written a code that said, hey, if we've traveled
this
this amount of
much.
distance
Yeah.
and we're still moving, then stop.
All right. So for now, how were you doing it? Right? Were you like estimating what the size of the loop was? Or, um. in your original, right, you had to find a mechanism of making it stop. How did you do it if you were not keeping track of how far you've gone? Right? What was
I
your
was just
base to say I have arrived, or to let the robot know that it has arrived? What was your base value?
the base value is where it started right here, where it first tracked the first odometry point.
Okay, so you kept that as your initial. All right, all right, all right.
Yep, yep.
So if it doesn't hit that mark, that exact XY coordinate, then it feels like it has not reached. So it keeps going.
Mhm.
I
Yeah.
see.
Mhm.
I see. All right. All right. Very nice. The other thing I wanted to ask you about is hang on one sec. So you made use of the odometry recorder, right? And
Mhm.
let me guess, you used an action. Is that right?
Yeah.
Right. So can you please
Where
get
is it?
into the details? Can you explain to me what is the difference between an action and a service, right? Can you describe in detail how they work and how they differ from each other? Why did you choose an action instead of just a service?
I chose right here. Let's see. Let me see. Hmm. Um, I chose an action just because it's it was just the only thing going to this thing. I didn't choose a service. That's pretty much all I got.
Um,
Um, as
or,
for the difference between an action and a service,
mm-hmm.
I know that there's you can have what was it again? Was it one client per action, or was it? I think so. And I know you can have multiple clients, or what is it? No, subscribers to a server. I think so.
Right. Okay. Because the thing is,
Hmm.
when you had to make use of an action, right, to keep track of odometry,
Hmm.
there's a reason why you had to choose that, right? Because for your
Yeah.
wall finder, you made use of a service, right?
Yes.
And then your your service client would say, find me a wall, and then the server would go along and find the wall. After it finds the wall, then it returns something to the client, right,
Hmm.
to
Yeah.
tell the client that I have found the wall, right? So from that logic, you do understand that actions work in a similar manner, but this is a
Yeah.
very big difference that I want you to find to understand why you had to choose an action versus a service, because they do work in almost similar ways, but there is something subtle that they do differently, right? Two things, in fact. That's what I wanted to find out from you. Do you understand those? But anyway, it's all right for now. Let me see if I have any questions for you. Not anymore. All right. Thanks for your presentation, Jose. So what we'll
Okay.
do is we'll finish our conversation on Zoom. Let me just do a wrap up here, and
Mhm.
we'll continue. All right, everyone. So this was Jose's presentation, and we highly encourage all those who would like to try the courses we offer certification on to give them a try and come make a presentation and show us how much you have learned from them and what you have learned, how you managed to do your project, what you did differently. And until next time, keep pushing your ROS learning. Bye bye.
Bye.